Sample problem. A fuel mixture consisting of hydrazine, which is N2H4, and dinitrogen tetroxide, N2O4, was used to launch a lunar module. These two compounds react to form nitrogen gas and water vapor. If 150.0 grams of hydrazine reacts with sufficient dinitrogen tetroxide, what mass of nitrogen gas is formed? So, first things first, start off with our equation. So here is our formula. Okay, the formulas and the actual equation and balanced. So, what do we have? Well, we look at the information. We've got 150 grams of hydrazine. Okay, so 150.0 grams. We want to find what mass of nitrogen gas. Okay, so that's our X. So X grams that are actually formed when these are combined. So what we're looking at is, now when we're listing, we're not listing within, we're listing now between the reactants and our products. So let's start off with our list. So we have moles, we have molecules, okay, and we always list the unknown. So the unknown is nitrogen gas and hydrazine, N2H4. So we know we've got X number of moles, but we're trying to find X number of grams, but we're going to treat it as moles because we can ultimately find that down the road once we've calculated our moles. So now we cannot put this in here because we are looking for the number of moles, and in order to do that, okay, we need to convert to a molar mass, number of moles. So we need to find the number of moles by taking the mass and dividing it by the molar mass. So let's do that for last. Let's do that after. So how many molecules of nitrogen do we have? Well, we have 3 molecules of nitrogen to a ratio of 2 molecules of hydrazine. So now let's go back. Let's try to find the actual the number of moles. So we've got 150.0 grams, and we're going to divide it by the molar mass of hydrazine, which equals to 32.06 grams per mole. So grams cancel out, and it leaves us with 4.6 moles. Okay, so that's what we get. 4.6 moles of hydrazine into H4. So, same thing as we said. We separate these two, okay, with our equal sign, and we have X over 4.6 equals 3 over 2. We want to isolate for X, so we're just going to bring the 4.6 over. So we get the following. X, and this is going to be X moles, okay, of nitrogen is equal to 4.6 moles, okay, of hydrazine. Many things. Okay. Times 3 molecules, okay, of nitrogen divided by 2 molecules, okay, of hydrazine. So hydrazine cancels out, molecules cancels out, and the unit that I'm left with is moles of nitrogen. So when I multiply 4.6 by 3 and divide it by 2, I get 7.019 moles of nitrogen. Okay, but I'm asked for the mass of the nitrogen gas. So again, we use this relationship, but we're given the moles. We have to find the molar mass. So we are going to multiply what we just found moles of N2 times the molar mass of nitrogen gas, which is 28.01 grams per mole. So now notice here, moles cancel out. My answer is in grams, and I'm left with 196.6 grams of nitrogen. And remember, 4 significant digits are the least number of significant digits in my question, so I have 4 significant digits in my answer.